Hi everyone and welcome. In this video we are going to see how to integrate this to Modbus IO card with the KEP server. Okay, so we are going to create the KEP server Modbus channel and we are going to control this to Modbus IO card from the KEP server. So this to Modbus IO card is serially connected with this ZLAN5143D gateway, and this gateway is converting Modbus serial data into Modbus TCP data. Okay, and I have connected this gateway via LAN cable to my laptop. So we are going to connect with this to Modbus IO card from the KEP server, and we are going to fire this to LED from the KEP server only. We are going to change the output voltage from the KEP server. Okay, so everything we can do in the KEP server, and once we have connected this to Modbus IO card in the KEP server, we can use any SCADA platform to connect with the KEP server and to operate this to Modbus IO card. Okay, because KEP server is able to connect with any SCADA platform. Okay, like ignition SCADA, plant SCADA, or even you can use Node-RED. Even you can directly convert this data into MQTT data. Okay, even if you log the data into database, so everything you can do in the KEP server. So that's why we are going to integrate this to Modbus IO card with the KEP server. So here I have my KEP server open. Now we will go to connectivity, and then we will create a new channel, and our channel will be Modbus channel. Okay, so it will be our Modbus TCP/IP Ethernet channel and our channel name. So you can see this to Modbus IO card is brought to you by the Augmatic Technologies Private Limited. Okay, so we are going to name our channel like WITTELB. Okay, and we will press next here. Again we will press next. Network adapter we will leave it as a default. Okay, yeah, here we will select port 4196 because this Modbus TCP port is linked with this gateway. Okay, so this gateway is having IP address of 192.168.1.200 and the Modbus port is 4196. So that is why I have to use 4196 as a port. Okay, and then we will press next, and then we will press finish. Now we have to add a two device. Okay, we have this two device, 4DDAM Modbus IO card and 4AOMV Modbus IO card. Okay, so we are going to add it here. So it's 4DDAM, and then we will press next, Modbus model. Now we have to specify the IP address and the slave ID. So IP address is 192.168.1.200 and the slave ID of this Modbus IO card is 1. Okay, so that is why I have to write 1 here, and then we will press next, and we will press next again. Okay, and here instead of port number 502 we have to use 4196. Okay, and then next again, next, and here we have to press on finish. Then we will add one more device, which is our 4AOMV. Okay, so 4AOMV, and then we will press next. Data model is Modbus, so we will press next again. Now we have to write the IP address. So our IP address is 192.168.1.200 and the slave ID for this Modbus IO card is 8. Okay, so I have to write 8 here, and then I have to press next. Okay, I have to press next here, next, and next again. And here instead of port number 502 I have to use 4196. IP protocol is TCP/IP. Okay, I have to press next here, and I have to press on finish. After that we have to add a tag. Okay, so tag in the sense we have to add coils on which we are getting the data, or on which we can change the data to operate this to LED or to operate this voltmeter. Okay, so first we will add tag for this 4DDAM module. Okay, so in this module, okay, in this Modbus IO card we have 3 channels: analog input channel, digital input channel, and the digital output channel. Okay, so we know the coil number and holding register address of this Modbus IO card. So according to that we have to add it here. So this is my DO1. Okay, and the DO1 is for this address. Okay, this coil address, and I have to press here 1. Okay, now I have to copy this 4 times and I have to change the address here. Okay, it's for my DO3, it's for, I'm sorry, it's for Yeah, DO2, this is for DO3, and this is for digital output 4. Okay, then after we have a digital input, so for that we have to create one tag like DI1. Okay, and address for that DI1 is 0005. Okay, and we have to press enter here. Now we have to copy this tag 3 times, and we have to change the address here like coil address 6, and here coil address 7, and here coil address 8. Okay, after that we have to add holding register for this analog input channels. Okay, so for that we have to create a new tag. We have to give a name as a AI1, and the starting address for this is 40,002. Okay, and I have to press OK here. Now I'll copy this tag 4 times. This is for 40,003, this is for 40,004, and this is for 40,005. Okay, now we can check the status of all this register in the OPC quick client, but you can see the quick client is disabled. So what we have to do is we have to connect the runtime here. Okay, no. Okay, the runtime is started. Now we can go to OPC quick client to see the status of this all register and the coil. Okay, so I have opened my quick client. We can go to our device. You can see DI1 is high because DI1 is connected with my sensor. So if I place something on my sensor, then you will see DI1 is 0. Okay, now what I want to do is I want to turn on the green LED. Okay, you can see here the green LED. I want to turn it on, so I can turn it on from DO1. Okay, so I have to right click here, and then I have to do synchronous write. I want to turn it on, so if I write value 1 and then if I do apply, then you can see the green LED is turned on. Okay, now if I want to turn on the red LED, then I can do for DO2. Okay, DO2 the value 1 and apply. Okay, if I want to turn it off, then I can write 0 again and then I can apply. And if I turn off my green LED, then I can do right click, synchronous write, and the value 0. Okay, so this is how you can operate your digital output from KEPServer, and you can read the sensor status in the KEPServer. So if I place anything on the sensor, then you can see DI1. Okay, you can see the highlighted row. DI1 will be 0 when I place part on my sensor, and if I remove the part, you will see the value is 1. This is the NPN sensor. Okay, so that is why whenever I place part on the head of sensor, it will give me 0 voltage. Okay, and whenever there is no part present on the sensor, it will give me 12 voltage. Okay, so that is why whenever there is no part present, it will show high, and whenever there is a part present on the sensor, it will show 0. Okay, now we have to add holding register tag for this Modbus IO card for analog output, so we can make a change to this DC voltmeter readings. Okay, so let me close this one. We will don't save it, and we will go to 4AOMV. We will add tag, so it's our analog output 1, and the registered address is 40,001. Okay, we will copy this 4 times and we will change the address here. So 40,002, 40,003, and 40,004. Okay, now we will again go to quick client, and we will scroll down and we will go to 4AOMV. Now the AO1 analog output 1 is connected to this DC voltmeter. According to the row value I provide here, the voltage will vary on this DC voltmeter. So if I write some value, suppose I do synchronous write, and if I write a value like 20, okay, you will see some change like 0.17 voltage is showing on the DC voltmeter. If I write the value 200, okay, you will see difference on the screen like 1.61 voltage. Okay, if I write 500, okay, so according to that you will see the voltage on the DC voltmeter. Okay, so you can use KEPServer to integrate this to Modbus IO card, and then you can use KEPServer connection with any other SCADA platform. Okay, it can be General Electric SCADA or it can be Immersion SCADA, whatever SCADA it will be. You can integrate a KEPServer with those SCADA, and then you can directly operate this to Modbus IO card from your SCADA system. Okay, now only one thing is pending, that we have to check the values of AI1. Okay, now I have connected AO2 with the AI1. Okay, so analog output 2 channel is directly connected with the analog input 1 channel. Okay, so if I go to here, you can see analog input 1 value is 0. Okay, if I change the value to analog output 2, then you will see some proportional change. Like if I write 400 here, okay, and if I go to this, you can see the value is updating here. Okay, so this AO2 is connected with the AI1. So whatever analog output I am giving to the external world, based on that, the value of AI1 will change. Okay, so if I again change the value to 700. Okay, so previously it was 190 around. Now you can see 348. So it will change proportionally, and you can see the update count. So this is that much update we have on this tag. Okay, and here you can see the update count. Okay, it is reading continuously. Okay, so why we have more update count here? Because it is reading continuous values. Okay, and you can see the voltage is fluctuating as well. Okay, so that is why we have more update count here. Okay, so this is how you can integrate this to Modbus IO card with the KEPServer, and this to Modbus IO card is brought to you by the Augmatic Technologies Private Limited, and they are the manufacturer of this card. Okay, so this is the Modbus serial card. You can also visit their website, or you can also call there on the salesperson number to get a Modbus TCP IO card. Okay, along with the Modbus serial IO card, they also manufacture Modbus TCP IO card. So you can also buy Modbus TCP IO card in case of your requirement. Okay, so I hope this is clear to you, that how you can integrate this to Modbus IO card with KEPServer using Modbus serial to TCP converter gateway. We can directly integrate this to Modbus IO card with the KEPServer with ATC converter. That is also possible. So if you want to directly integrate this to Modbus IO card with the KEPServer with Modbus serial communication, then instead of Modbus TCP channel, you have to use Modbus RTU serial channel. Okay, so if you use Modbus RTU serial channel, then you have to connect this to Modbus IO card with ATC converter, or you can say USB to serial converter, and then you can directly connect this to Modbus IO card with the KEPServer, and in that also the addressing will be the same. Okay, the no addressing will be changed. Only thing it will change is the connection parameter. For that you have to provide the serial connection parameter like baud rate, parity, stop bit, and the data bits. Okay, but if you are connecting via TCP communication, then you have to provide the IP address and the port number. Okay, so that is the main difference between this serial and TCP connection. Okay, so I hope everything is clear to you, and if you still have any question or any doubt, then you can ping me on Telegram, Instagram, WhatsApp, anywhere. Okay, so I hope everything is clear, and we will meet you in the next video. Till then, take care, goodbye, and thank you.